Dear partners, hello and welcome to our second ever workshop. The first one was dedicated to the problem of thin object scanning. So if you're still having difficulties with this type of objects, feel free to download the recording from Artec resellers portal. Today, we're going to address another exciting challenge that our users face, which is combining data from different scanners. We called it a workshop for a reason, as I will be practicing what I'm preaching online with you. So if you have any questions, just as always, feel free to either ask them in the chat window or maybe unmute yourself along the way and ask the question out loud. All right, so without further ado, let me share my screen with you. Okay. Sometimes we find ourselves in a position where we want to have an exceptionally detailed resolution or higher accuracy in certain areas. It also occurs that we need to scan a difficult to reach zone of an object and are unable to scan it with one particular scanner because of the size of its field of view. So in cases like these, we resort to the practice of combining data from several different scanners. To outline possible combination options, I'm going to get ahead of myself a little bit and say that there are two possible combination scenarios. In the first case, we combine raw data or scans, and the second approach implies combining fusions. With that said, the raw data combination scenario, or option number one, leaves us with the following scanners options. Okay, so as you can see, raw data from our handheld scanners can be combined without any limitations whatsoever. So when we want to combine raw data from Ray, things get a bit more interesting. To combine anything with the data from our long-range laser scanner, scans made with Ray need to be either triangulated or fused first. This limitation is attributed to the different format of data that Ray generates. And once we've done that, raw scans from Leo, EVA, or Space Spider can be aligned, registered, and fused together with Ray's triangulation or fusion. You might be wondering why we left out our precision front-runner micro. The thing is, with regard to combining data from micro, it is no different from any of our handheld scanners. So technically, you can combine it with anything, but we cannot really think of a scenario where such combination would make sense. Now, if we are talking about the second scenario that revolves around combining fusions, we don't have any limitations whatsoever. So any fusion or triangulation can be fused with another fusion. Behind the apparent simplicity, processing of combined project has got some tricks that you need to be aware of. And today, hopefully, we'll cover all of them. We'll go over some of them at least one by one. Now, before we move on to practice, it's time to introduce the combining workflow number one, but also the main star of the show, which is that lovely crankshaft. So this is a part of a large vehicle. As you can tell, it's about 1 meter long, and we scanned the whole thing with the Leo HD, obviously. But then we focused on the top part right here, and we scanned it with the Space Spider because we want to have some additional resolution and accuracy in that area. Okay, so now let me share my screen back with you, and let's go over the first workflow, or the first combination scenario, which revolves around combining raw data or scans. At the very first step, we just scan the object using EVA or Leo scanner as much as necessary for our particular purpose. And then we scan parts of the object requiring additional resolution and accuracy with the Space Spider. At the second step, we separately process just the Leo or EVA data. We make sure that the Leo or EVA preset is selected in Artec Studio and process the data in a regular fashion, but stop before making the fusion. The third step is pretty similar. We do the same for the Space Spider data set. So we process just the Space Spider data. We make sure that the Space Spider preset is selected. We process the data in a regular way up until the fusion stage. All right, the fourth step is extremely important in this case. We need to lock the process Space Spider scans through the use of the lock registration feature. Having done that, we will switch preset back to EVA or Leo and align both datasets together. So we're going to align EVA or Leo dataset with the Space Spider dataset. The sixth step is to perform global registration of the EVA or LEO scans with the locked spacebar scans. After that, we're going to have to use eraser to remove the high resolution surface area from the LEO or EVA scans. So this is necessary for obtaining additional resolution or accuracy in the selected areas. And last step, obviously, we need to fuse the combined data from both scanners together. Okay, now let me switch to Artec Studio, and we're going to go over every single step right here, right now. So let's start with the spacebar dataset. I'm going to select the spacebar dataset. The first thing I want to make sure is that I'm using the right preset. So obviously I'm going to have to select, the spider preset and align my scans, because it took me 4 scans to capture that area in high details. So in that case, I'm going to rely on auto alignment because I got 4 scans, so I don't really want to align them all by points. So I assume that it's going to take less time using auto align here. Okay. As you can tell, auto align has done a pretty decent job. Now we need to register our spacebar scans. I'm going to use the default settings. And even though we've still got some misalignment here, I'm pretty sure global registration will be able to take care of it. Because at the alignment stage, we only do like the first iteration of positioning, and we don't really mind a few frames sticking out. So when we register everything right now, we're going to need to lock our spacebar scans. And the reason why we want to do that is because we've got another registration coming ahead. And the problem is, if we don't lock them and we run another registration with another preset, it might tamper with the quality of the first registration. So by using the registration lock feature here, we make sure that the respective position of all of the frames within the spacebar scans stays the same. Okay, the registration is done. I'm going to lock my spacebar scans. Now it's time to move on to our LEO's dataset. So I'm going to switch the preset to Leo HD. Okay. I'm going to use only Leo scans. Again, we're going to have to align them first because I didn't pre-align them. So this time around, I'm going to do that by specifying a certain number of point pairs. And all right, let me see. What is the best way to align them here? Okay, I'm going to use that side. So as you know, 3 point pairs is just enough. But I personally prefer to go an extra mile and specify at least 4, maybe 5. We also need to make sure we don't select them on the same plane, or that these points don't make up a straight line, because this is not going to be helpful for the algorithm. Okay, that's going to be the scan number 1. All right, and here's the last one. So the last patch, I'm going to be aligning to that place right here. So again, the same thing, 3 points. Okay, and another one right here. Nice. Okay, now everything is aligned. So I'm going to bring back my spacebar scans that I have locked. Again, the preset that we're using right now is Leo HD, and we need to keep this preset for that last global registration. But before we register everything, we need to align it together. So again, I'm going to get back to the alignment tab. I'm going to align my spacebar dataset to the Leo dataset. Again, about 3 points will do. Okay, the alignment is done. Now we can actually go ahead and run global registration. So for that uniting global registration, we use the preset of the scanner that has covered the most surface. So in our case, obviously, it is Leo. So we go to the tools, make sure that the Leo's preset is chosen or is selected. And yeah, let's run global registration. And I'm going to keep my scans locked, obviously, because that's the whole point here. Right. So as we established earlier, one of the further steps of the combining workflow is eliminating overlap between higher resolution and lower resolution data sets. And that step is relevant for both scenarios, regardless whether we combine raw data or fusions, it doesn't really matter. So the idea behind this step is that we should avoid any possible conflict in the high resolution area that could potentially compromise resolution. There's an ongoing discussion about whether it is better to delete overlapping area or just leave everything as is. I personally am inclined to say that indeed it is better to delete these overlapping data and thus avoiding the risk of the lower resolution data merging together with the higher resolution data. But we know for a fact that some users get perfectly satisfactory results despite neglecting to delete this overlap. So it kind of depends on the project, but if you want to play safe, I would suggest erasing the overlap. If you don't do that, you might well still get some satisfactory result. Okay, now let's get back to our project right here. So registration has been done successfully. So everything looks just fine. Now, when we are erasing the HD region from a lower resolution data set, we should still leave a bit of an overlap, just a narrow strip of surface between the fusion or the groups of scans to decrease the chance of geometrical defects in that transitional area. So I have got another project to demonstrate you something. So here, I've got that nice item right here. As some of our users pointed out, this step might be quite tricky to execute as we don't have any means of preventing scans or fusions from the effect of the eraser tool, like we do with global registration and the lock functionality. But there is one technique that I would like to show you that introduces an easier solution for the aforementioned problem. So let's say we're trying to combine that lower resolution data set with a higher resolution data set right here. So now we need to erase that part from the lower resolution fusion. So the problem with that is to select everything precisely, we need to have both of the fusions selected as visible. So when I go to the, to the eraser tab, I have both of these visible. So now when I'm selecting geometry, I'm going to be selecting it on both of my fusions. So, okay, let's select it first, and then I'm going to show you what I'm going to do next. We need to select the region that we are trying to erase from the lower resolution fusion, but don't forget that we need to still keep a bit of an overlap between them. So I'm going to select that area right here, but I'm going to still leave a narrow strip of surface between them. Okay, so as you can see, that area has been selected not only on the SD fusion, but also on the HD fusion. So now if I click erase, it's going to erase it from both of these fusions, which doesn't make that much sense for us. So again, if I click deselect, it's going to deselect it everywhere, regardless on which fusion is highlighted right now. So one of the ways around it is that we select higher resolution fusion and we deselect the geometry from here manually. So I press Control Alt and deselect everything with the deselection tool. Now, when I get back to my smaller resolution fusion, everything is still selected here. So now if I click erase, it's going to erase it from the lower resolution fusion, but for the high resolution fusion, everything stays the same because we deselected that geometry. So let me do it once again. Now we've still got that that high resolution area on the SD fusion. So I'm going to highlight both of these. I'm going to select everything that I'm going to erase, leaving a narrow strip of surface of an overlap between my fusions. Okay, there you go. Then I'm going to leave only HD fusion selected and deselect geometry manually. Right. Now I'm going to bring back my SD Fusion as well, click erase, and as you can see, it has only erased it from the SD Fusion. So now we've got both of the fusions right here. They do have some overlap, and technically we're ready to fuse them together into one final model. Okay, so let's do that for our item right here. Before I erase it from the Leo's scans, before I erase that area, let me make sure that I erase everything I don't need from my space spider dataset. So the only reason why I captured that flatter part of the item right here is for better tracking and registration. So now before anything else, I'm going to erase it, and I'll only leave that top bit, which I want to have in high details. Okay, so I think that area is what I'm looking for. Okay, reverse, erase. All right, so that is the area that I'm interested in. This is what I want to see in high resolution. Okay, now it's time to erase that particular area from the Leo dataset. So again, we're going to go back to eraser, select the area that we want to erase. Okay, I'm going to use 2D selection with the select through option turned on. Again, now I've selected it on both datasets, Space Spider and Leo dataset. So the first thing I'm going to do is I'm going to select my Space Spider dataset and manually deselect it from here. So now it's deselected from the Space Spider dataset. I'm going to bring back my Leo dataset, and since I was using select through, I've also selected a whole bunch of stuff which I do not want to erase. So I'm going to deselect it as well. Okay, deselect it. And now I'm going to erase that top bit, which represents the higher resolution area that we want to, that we've scanned with the Space Spider. So this is what we're left with. All right, so having erased the overlap, we need to answer like a very important question. But before we do that, let me start Fusion, because it's going to take a few moments for the Fusion to generate. Okay, anyway, now we reached the stage when we need to make a very important result-defining decision and choose resolution for a final fusion. So we are combining data from Leo and Space Spider, and the latter has superior accuracy and resolution, and we want to take full advantage of that. But at the same time, we should acknowledge the fact that the majority of the surface was captured with Leo, and we cannot use Spider's resolution for that area. If we still decide to do that, though, we will almost certainly get artifacts such as artificial wavy pattern, the infamous orange peel effect, or holes across the entire part. Unfortunately, there is no one-size-fits-all kind of solution here, so we cannot recommend you one or multiple numbers, resolution numbers, that will be suitable for every single combined project. But there is a solid rule that you could follow. So the rule goes as follows. If you follow it, you will be able to get the best resolution and avoid artifacts. So the rule is look at the max error numbers for both scanners datasets and decide what resolution you would use if you were to fuse these datasets separately. Then calculate the middle resolution and apply it for your combined fusion. You won't necessarily get the best possible result with your first fusion, but it's going to be a great starting point. So if that fusion with the middle resolution looks great and there are no apparent artifacts, you should create another fusion and go one step higher with your resolution. In cases when you spot artifacts, do exactly the opposite and go one step lower. So that way, after 1, 2, or 3 iterations, you will identify the best possible resolution parameter for that particular project, which will always differ depending on the size of the item, scanners used, features present, or some other unique parameters. Okay, now let me show you another project which I've got ready to demonstrate what I was talking about. So check out this table right here with some items on top of it. Yeah, so we used regular EVA It was long before the HD mode came into play. So we've covered everything with regular EVA, and then we scanned some more intricate details of the scene with the spacebar. Okay, when we started creating our fusions, this is what we got. So this is the result of EVA. So this is what we can get if we scan the whole thing with EVA. As you can tell, the intricate details are not visible right here. But then we start combining our data. So that area was captured with a spacebar as well. So now, if we combine our spacebar fusion with the EVA fusion and use spacebar resolution, which is 0.2 in this case, this is what we get. So even though the intricate details of the item looks great, so spacebar data looks amazing, but if you put closer pay close attention to the data from EVA, you can clearly see some artifacts. So now we've got those waves appearing on the EVA fusion, which is not good in that case. So following the rule, we need to go a couple of steps lower with that resolution. So we refused it with 0.4 resolution, and this is the result. So although we've lost some of the details, that parasitic pattern, wavy pattern is still present. So again, this is not the optimal resolution in that case either. Okay, now we fuse it again with 0.6 resolution. So now the geometrical pattern of the table looks more natural, no artifacts present. And the previous fusion was 0.4, this one is 0.6. So obviously we can go ahead and try 0.5 because it's somewhere in between. So the last fusion is 0.5. Nothing has changed with regard to the artifacts on the EVA dataset, but we can still see a bit more details than we did on the 0.6 fusion. So 0.5 resolution is the optimal number for that particular project because we don't get any artifacts, and at the same time, we still get some, well, a pretty good boost of resolution for the intricate area that we've captured with the spacebar. So again, this is what we get with EVA only. And this is what we get from combining data from two different scanners and using 0.5 resolution for the final fusion. Right, now let's get back to our project. The fusion has been finished, so this is what we get as a result. As you can see, Leo's data doesn't look half bad, so we can still see a lot of details here, so it looks great. But it's still not quite up there with the spacebar because spacebar's resolution is superior, and that's exactly why we decided to combine these two data sets together. Also, since I've touched on the artifacts, let me show you one more thing. This is the model that I'll introduce to you a bit later, but if you spot those holes on the Ray's data set, because that whole thing was scanned with the Ray, and a certain part of it was scanned with the Leo. And then we combine these two data sets together, and we fuse it with the resolution, which was irrelevant to the Ray's data set. So it was too high for the Ray's data set. And this is why we've got all of these holes appearing here. It's just one of the ways the bad choice of resolution can mess up your project. So please be careful with that. Right. Now I'm going to export that model right here, and then I'm going to import it to the second project, which will be processing of the same item, but with a different scenario. And then we'll be able to compare the two fusions against each other. And we'll also add the Leo fusion and compare these three against each other. So now that we know what we can expect from the first scenario when we combine scans, let's move on to the second scenario. Please welcome scenario number 2. The first step stays the same. We collect our data, we scan the object using either a Leo scanner as much as necessary for that particular project. And then we scan parts of the object requiring additional resolution or accuracy with the spacebar. At the second step, we separately process just the Leo or EVA data. Again, we need to make sure that the right preset is selected. And we process everything in a conventional way up until we get an unsimplified fusion. Step number 3 is do exactly the same thing for the spacebar data. So we need to get the unsimplified fusion And again, please pay attention to the preset that is selected because it's crucially important. At the next step, we need to switch the preset to Eva or Leo. Well, because here Eva or Leo has covered the most surface, and we need to align these two fusions together. Step number 5, global registration. So even though we operate with fusions, we still need to align them against each other tightly with global registration. Step number 6, you're already familiar with. So we need to remove high resolution surface area from Eva or Leo fusion, right? So that we don't merge these two data sets together to avoid some artifacts and some interference of the smaller resolution area with the high resolution area. Step number 7, we fuse these two fusions together. Okay, let's do all that with the same project. So again, the first step is collect our data. We've got everything right here in front of us. Then we switch the preset to Space Spider. So let's say I'm going to start with Space Spider, not the Eva or Leo in that case. So I'm going to go to Tools, switch it back to Spider, align my scans, run registration, and run fusion. So I did a bit of a pre-processing here, as you can see, just to save up some time. So I've done alignment, done registration, and here is the fusion that we've got as a result. So this is the Space Spider fusion. The resolution was 0.3. Then we're switching to Leo. So we need to go to the Tools panel and switch the preset to Leo HD. Leo HD, there you go. And then we do exactly the same thing for the Leo dataset. So we align the scans, we run registration, and we run fusion for them. So this is the fusion of Leo. Okay, so now we operate with these two fusions. The next step of processing is to align them together. So we're going to go ahead and align these two fusions just like we did with the raw data sets. It is no different, still 3 point pairs. Well, at least that's like the bare minimum. If we specify 4, it will never hurt. So here's the 4th point pair, align. Okay, there you go. Right, so now quick registration. Again, we are still keeping the Leo's preset here. If I was using Eva, I'll be using Eva's preset. So global registration, default parameters, apply. Yes, I will run it in geometry only mode because we don't have any texture to rely on here. Again, one more time, I'd like to reiterate the importance of using the right preset. Probably sound like a broken record, but the thing is, presets control a whole bunch of internal parameters which we otherwise do not have any control of. So we can control keyframe ratio, feature search distance, but there is also a large number of other parameters that play a great role in almost every single algorithm, which means we need to make sure that we use the right preset. Otherwise, the results that we're getting can be quite unpredictable. Okay, the next step is erasing overlap. So again, exactly the same what we did with the raw data sets. But first, I'm going to select my Space Spider fusion and erase everything that I do not want to see on my final fusion. Okay, so I'm going to keep that, I think, and the rest I do not need. Okay, beautiful. And now I'm going to do the same thing. I'm going to select everything first, like that. Then I'm going to deselect it from my Space Spider fusion with the manual deselection tool. Okay, then I'm going to deselect everything which I falsely selected because I used select through option. There you go. Okay, and now I'm ready to erase it. So 2 fusions, the high resolution area is erased from the Leo fusion, but clearly there is overlap between them. So this is exactly what we are looking for here. Okay, so now it's time for the last step, and the last step obviously is fusion. I'm going to go ahead and use the same resolution. So for my Leo data set here, I would use 0.5. For my spacewater, I would use 0.3, which means I'll meet somewhere in the middle and fuse it together with 0.4 resolution. And I use the same resolution for the previous scenario as well. So 0.4. Now, while we're doing it, while we're fusing everything together, you might be wondering how you choose between the scenarios, because we've got two, and obviously there is some difference between them. So while both of these scenarios get the job done, you should be careful with the choice between the two. Each of them has their pros and cons. Fusing raw data is clearly a more natural way of combining data. So that method is unlikely to disappoint you with any artifacts or anything like this. Another important advantage of the first method is that it doesn't require any further editing, because there is no visible border between the regular and the HD areas that need to be smoothed out. Okay, however, as you will see later, combining fusions allows you to get superior resolution in the HD areas at times. So if that is your main concern and you don't mind using smoothing brush to iron out some of the surface inconsistencies in that transitioning area, you should employ the workflow number 2. Please note that the second method, when we combine fusions, is more prone to generate artifacts. So when I say that you might get better resolution with the second method, what I actually imply is you will be able to get higher with your resolution for your final fusion, right? And that way you will ensure better resolution of that intricate area. Okay, let's get back to the model right here. So we've got it. This is what it looks like. The combined fusion, the resolution 0.4, still looks great. The thread is still here. So all the fine details that we were trying to preserve are present right here. Okay, now let's actually go ahead and compare them with what we got previously. So here's the Leo plus Spacewater 0.4 fusion. So the fusion that we got with the first scenario. And then we're going to load up the Leo fusion only that we fused with the resolution of 0.5. Okay, 0.5, there you go. So first off, there will be a massive difference between the Leo only fusion and any of these two fusions. It will be quite clear. But the million-dollar question is, do we get any difference between the scenarios? So first of all, this is what we would get if we did not use data from Spacewater. Again, it doesn't look half bad unless you've seen what Spacewater has to offer. So this is what we got with combining two fusions. And this is the result of combining raw data. So if we sort of switch between these two, we cannot really tell the difference in this case. Well, the first fusion might be just ever so slightly sharper, but again, they are pretty much identical. So in that case, you could get away with using either of these scenarios and you would still get a great result. All right, now as we have established the combining workflow, let's go one step further and add Ray into the equation. Combining data from Ray with other 3D scanners may be of great advantage in cases like when the object has a number of hard-to-reach areas that cannot be accessed with the Ray scanner alone. When the object is easier to scan with the Artec Leo, but higher accuracy is required. And also when selective, high-resolution areas need to be added to a Ray scan of a larger area which was originally captured at a lower resolution. Generally, our approach to combining data stays the same. We still have the same two options. We can either combine raw data, keeping in mind that Ray's point cloud need to be triangulated first, or we combine fusions. But given an extremely broad spectrum of possible scanning distances, and a consequent fluctuation of accuracy and resolution, we will need to adjust our combining workflows a little bit. When scanning distance is shorter than 15 meters and ray is combined with EVA or LEO, we need to take into account superiority of ray's accuracy over accuracy of the handheld scanners. But at the same time, when scanning distance is over 20 meters, or we combine ray with space spider, then the handheld scanners are expected to outperform ray with regard to accuracy. For us, it means that in the first case, we should use ray's data as the backbone of the project and always register EVA's or LEO's datasets together with ray's triangulation or fusion. But in cases when we combine ray with space spider or scan at over 20-meter distance, we do exactly the opposite. We run registration for the handheld scanners datasets separately from ray's triangulation. Now let's put that scenario into practice and combine a part of a large machine scanned with ray and scans of more intricate areas made with LEO. And that is the machine that I'm talking about. As you can tell, it is absolutely massive. If I'm not mistaken, it's a part of old mining equipment. The whole thing was scanned with the ray, and then we added a certain part of it that was scanned with the LEO. So now let me go ahead and show you the project right here. So it's only a part of the scene, but yeah, let's say we scan the whole thing with the ray. And then we need to attach a certain part of the same machine that we've scanned with the LEO to our ray's data set. And this is the LEO's data set right here. All right, there you go. Okay, so the very first step of the workflow here is to process our ray's data, because we need to get that triangulation and fusion, because otherwise there is no way to combine it with anything. So we choose the preset, obviously. Then we align our ray's data sets, our ray's scans, pardon, and we run registration. Having done that, we create either triangulation if we had only one scan, or fusion if we had multiple. In that case, I've already done that. I had to do some pre-processing, just because otherwise it would take us way too long to do everything online. So there you go. This is the fusion of the race data right here. The resolution is 5.0. It's a pretty default resolution, nothing fancy here. Okay, then we switch the preset to EVA or LEO, depending on which scanner was used. In our case, it was LEO. We align our LEO scans. Here we had two. We run registration for them. So again, here I've already done that. I pre-registered it. And then we need to lock it, because there is another registration coming. So as you can see, my scans have been locked already. After that, we align them with the ray's fusion and run that final registration. So here is the aligned data set. All right, there you go. When I align it, when I register it with the ray's fusion, I obviously need to keep the preset on LEO, right? So I use LEO's preset, I run that registration, and this is what I get as a result. So now, technically, we've got two more steps. One step is erasing overlaps, and the last step is fusion. So in that case, I opted not to erase overlaps, and I ran fusion straight away. So as for the resolution, my ray's data was fused with the resolution of 5.0. Judging by the max error number of my LEO scans, I can use a resolution of 1.0 for the LEO data, which means for the overall fusion, for the general combined fusion, I can start at least with the resolution of 0.3. And this is exactly what I used here. So I fused both of these with the resolution of 0.3. And this is what I got as a result. So as you can see, the resolution is still great. So all these fine details, even though we kind of refused it. So and the resolution is 3.0, even though we could have used 1.0 for the Leo. All the fine details are still here. If we want to compare them against the Leo Fusion, we can do that as well, because I've got a Leo Fusion here. So let's go to alignment. Let's go quickly switch between them. So this is what it would look like if we only use Leo data. So that is the Leo Fusion. Resolution is 1.0. And this is the combined fusion of Ray plus Leo. The resolution is 3.0. So even though we have lost some of the details, it still looks great. Okay. So this is what we got as a result. We combined these two data sets together. A certain area was missing. We needed to add this area, and we wanted to capture it in high resolution. And yeah, mission accomplished. There you go. This is the final fusion. So yeah, I'd like to thank all of you for attending our workshop. It was really nice seeing you here. And hopefully we will see you later. See you during the next workshop or webinar that we'll be hosting in a couple of weeks. So thank you and goodbye for now.